unlike a transmission line, which spans for miles and miles and traverses through neighborhoods and suburbs and countryside, that's a long, continuous infrastructure project, but a substation occupies a site. So now you're more like a building. But to your point, there's usually a wall surrounding that, and it's like, well, don't pay attention to the man behind the curtain. There's a lot going on there. You mentioned the price of the equipment. It's also the lead time of that equipment. Most of the time, those transformers and those complicated switching apparatus are sourced overseas. And so there's a supply chain that affects the ability to recover if you were to have damage to any of those assets.
That's right. Some of those run 6, 8, 9, 12-month lead time to replace.
Absolutely. And so with that in mind, when we have a call, either for a program to go inspect substation structures, whether it be the stands or the dead-end structures, the big A-frames, or even the structures that are designed to protect that equipment from lightning strikes, the shield wire support structures or the static mast structures, those are there to protect that substation equipment from lightning strike. Makes sense. It's interesting, one of the projects that we got involved with last year was the failure of one of those static mast structures that just timber from the base of that structure, it fell flat on its face. So there's a structure intended to protect that substation that now has become a danger to that substation. That could have easily fallen a few degrees right or left and been on top of that very expensive transformer or switchgear. And so why did a structure that's in the substation fail? And so we got involved in looking at the root cause of that. Oftentimes, those structures are subject to that wind-induced vibration or vortex-induced vibration. Unlike many of the other structures on the power lines that connect substations, these individually standing structures aren't dampened by the lines themselves. They are up there, they're tall, they're typically subjected to a lot of exposure area for winds to pass across them. And many of them have been designed from the beginning for a damper of some kind, whether it be an internal damper or strakes that spoil the air that flows around them. And they oftentimes, even though they should be, oftentimes they aren't protected by those systems, and they aren't designed for fatigue type loading. And that was the case that we found, is this structure was plenty large enough to take care of the load, plenty tall enough to support the shield wire well above the expensive substation equipment, but it failed because it wasn't being inspected. It wasn't suspected to be a threat to the rest of the substation. But that happened with something that's not unfamiliar. There was a dynamic going on at the base of that shield wire structure that's not uncommon to transmission structures, or for that matter, the dead-end structures and other types of structures within substations. But it was allowed to go unnoticed and unaddressed and uninspected to the point that it failed. And we've seen multiple situations like that. You're not going to fix that failed structure laying on the ground, but you want to understand why it happened and what you need to do with the rest of the structures that are in that same substation, and for that matter, in any substation.